It is time to tackle the trapezoid section of your foldable. Find the trapezoid section. Let's check out the definition. So a trapezoid, it's just a quadrilateral. It's got the 360 degrees in it. But what makes it special is that it's got one pair of parallel sides. So marking that in the picture, in this particular picture, it's these two sides, top and bottom. They're running parallel to each other. The other sides are non-parallel. What do we call the sides that are parallel? We call those the bases. So I've got two bases, a long base and a short base. There's always a long base and a short base. These other two sides, those guys are called the legs. So two legs, two bases. Bases are parallel. Now, properties a trapezoid has. First of all, a vocab word. We need to get this out of the way. We're going to look at what's called the mid-segment. And the mid-segment is a segment of the trapezoids that's joining the midpoints of the legs. So I'm just going to be doing some eyeballing here, but come to this leg here, and let's just mark this might be the midpoint of it. Let's make tick marks on either side so everybody knows that's a midpoint. Come over to this side, and this guy right here, that's a midpoint. Of course, these guys are going to be different lengths than the first leg. When we take this segment that joins those midpoints, maybe I can do this with a straight edge. We take that segment right there. That guy is the mid-segment, or mid-segment. Now, why do we care about this? Well, we get a theorem. It's called the trapezoid mid-segment theorem. This is true for all trapezoids. That mid-segment is indeed running parallel to the bases. You might have been able to guess that. So we already know our bases are parallel. Mid-segment's just as parallel. So we got a set of 3 now. But its measurement, look at its measure. You'll notice this mid-segment, it's a little bit shorter than our long base here. And at the same time, it's a little bit longer than our short base here. So it's somewhere in the middle, and in fact, it's half of that sum of the bases. So we could say that easy way is it's the average length of the bases. So formula-wise, let's come to our picture. Let's call this base number 1. Let's call our longer one base number 2. And let's call our mid-segment M. Our mid-segment would equal the measure of our bases added together, and that measurement cut in half. So we're taking the average length of our bases. Another way to write that would be that it takes 2 of our mid-segments to equal the same thing as our bases added together. So either way, let's look at an example. Okay, so we get to figure out the mid-segment length. Notice these tick marks are showing us these are midpoints. And we know it's a little more than 24, but not as long as 30. So the way we're going to find that, let me put an X in here. So X is our mid-segment, and we would just take the 24 and the 30, the two bases, we're going to add them together, as you can see, and divide by 2. Let's do that. 54 for the total there. 54 divided by 2 gives me 27. So my length of this mid-segment is 27. And notice, 24 to 27, that's 3 difference. And 27 up to 30 is also 3 difference. So it's right in the middle. This example is going to be the same thing. Of course, we're going to sneak some algebra in there. Let's set it up this way. The two bases added together, so my bases are 8 and 4x minus 10. I'm going to add those together. I'm going to divide by 2 to take their average. Let that equal my mid-segment length, which is x plus 2. See how that works? So how do I solve it? Well, I'm going to multiply both sides by 2. On each side here, this guy needs to go in parentheses. So the 2's over here get to cancel, and that leaves me with 8 plus 4x minus 10. Maybe I should have collected those terms first. Make sure you're distributing this. 2 times each of those terms gives me 2x plus, right there's 4. Alrighty, so now I've got to combine these like terms. So I'm going to say I've got 4x, and 8 minus 10 gives me negative 2. Bringing this down, let's get the x's all together on one side. How about we subtract off the 2 x's, and let's add the 2 over. See what that gives us. Get a cancel. How many x's? We got 2 x's and 6 over here. So 1x alone would be just 3. So the value of x is 3. Coming back up, what were we supposed to find? Oh, we're supposed to find x. Let's plug it in. Yeah, let's do. So x is 3. That makes this mid-segment 5. And 3 times 4 is 12. 12 minus 10, that makes this mid-segment 2. Does it work out? Looks like that goes down by 3, and that goes down by 3. I'm lacking it. So x is 3, final answer. Okay, let's open up your foldable. Go to the definition of isosceles trapezoid. Now we've got special kind of trapezoid. So it is a trapezoid. You'll want to draw that arrow up. All that mid-segment work we just did applies to these just as well. But what makes it special is that it has a special relationship with the legs. Those legs, I don't have a long leg and a short leg. I've got two congruent legs, and that's a good thing to have, is two legs that are the same length. So these guys are going to be the same length. Well, what does that tell us about our trapezoid? If you'll open up your flap to the next side, we've got some special properties. Because those legs are congruent, the base angles are also congruent. This goes right back to our isosceles triangles. These guys, these angles here on the base, those are the base angles, and those are equal or congruent to each other. Now remember, we've got a second base right up here. This base has some congruent angles as well. Not congruent to the first set, but to each other. What else? The second property is about the diagonals. When you draw these diagonals in, the diagonals, the length from this corner to this one, and the length from the other diagonal, those two corners, they are congruent. Shouldn't be too hard to see that. And as far as tick marking goes, these upper portions are equal, and these lower portions are equal. So we do have a couple of isosceles triangles in there. Let's see how these theorems work in some examples. So here we have a trapezoid. You'll notice these tick marks. These tick marks are showing me it's isosceles, and just like triangles, I'm going to be able to point across to some angles, and those angles are going to match. So finding the value x is a matter of setting this base angle congruent to this base angle. In other words, it's 60 is equal to 5x. And dividing by 5, x is going to be 12. Base angles are congruent. This one's a little bit tougher because we've got a lot of angles to find and one diagonal drawn in. Let's tackle this first of all looking at what we do know. We know that we have a 70-degree angle right here is angle A, and we also know that it's isosceles. So that means that the base angle right over here, this entire angle made up of angles 1 and 2, this is also 70 degrees. That's a total of 70 degrees. Now 1 and 2 are splitting that 70 degrees, probably not equally, but in parts. What else do we know? Right up here we have these base angles in purple. I'm going to mark those, and these angles are congruent also. I don't know either one of those. So one last thing I'm going to point out to you, and I'm going to get the highlighter to do this, is that these are parallel lines. You need to remember that parallel lines are giving you some angle information. Let's run down this transversal right here, for example, and look at that Z. See that, baby? All right, so that 50-degree angle up here at the top comes right on down here to angle 1, and it tells me that angle 1 is also 50 degrees. So now we're on a roll as far as figuring out some measurements. Angle 1 here is 50. That should tell you that angle 2 makes the other portion to make 70 total, so angle 2 is going to be 20. All coming from that Z angle. All right, now with that we should be able to figure out pretty much these other angles. Let's take angle 4 for example, and I'm going for angle 4, I'm going to the triangle. The triangle right here at the top. I've got a 50-degree angle and a 20-degree angle. So 50 degrees plus 20 degrees plus angle 4 is making a whole triangle 180 total. So that would mean angle 4 by itself would be just subtract off this 70 degrees right here. Angle 4 is going to be 110 degrees. Let me put that in my picture. 110 for angle 4. Alrighty, what about angle 3? Well, angle 3 is also on a triangle. And on angle 3, that triangle would be 70 degrees plus, what's angle 1? Angle 1's 50 degrees plus whatever angle 3 gives us. That's going to make up a triangle of 180. So if I take away, that looks like it's 120, and let me take 120 away from 180, and that makes angle 3 60 degrees. Let's stick that in the picture. All right, so there we go. We found all the missing angles, and before we leave this, I do want to just point out this total right here in angle D. We've got a 50-degree part and a 60-degree part. What's the total of that? 110, and notice that it matches the 110 right here. Since, of course, this was isosceles, I want those base angles to be a match. Love it. Next example. It's our turn to draw our own picture. We're going to draw a picture of trapezoid, TRAP, that's isosceles. So let's go with an isosceles trapezoid. Let's mark that it's isosceles, get those legs the same. And right here it tells us how to label it. TR and AP are equal to each other. So the two legs are TR and AP for the other leg coming around. So we got TRAP. Looks good. And from T to A, that's 19. Now T to A looks like that would be a diagonal. We're going to go 19 across right here. And it's our job to figure out what RP is. Well, this isn't too bad. RP is the other diagonal. We just saw a theorem that said that those diagonals are going to match. So this is just to pretty much draw the picture and you'll see the answer. From R to P, it's the same thing as it is from T to A. So R to P would be 19 just like TA is. Matching. How about this guy? This is isosceles. See the tick marks. There they are. Congruent legs. And we're going to find the lengths of the diagonals. Let's look at our given. We know from S to U here is x plus 1. And from T to R right here is 2x minus 3. What do we know about those? Those diagonals are congruent. Let's set them equal to each other. So S to U is the same as T to R. And let's just plug those in. X plus 1 is our SU. And TR is 2x minus 3. Solve it. I'll play you some music while you do. Come back and check your answer.
Has many shapes. Trapezoid. Many shapes has quadrilateral. A trapezoid is 1, 2 parallel. But the other two are not. Right arm, left arm, right leg, left leg. Quadrilateral.
Okay, here's what I came up with. I got x is 4. Check that work. I didn't show the crossouts. Let me do that. Here we go. Those are gone. X is 4, so let's go plug that value of x into the segment expressions. So 4 plus 1. 4 plus 1. Think about that. That's 5. And on TR, we're going to go 2 times 4. Minus 3. Also 5. Diagonals match. Now to try these, they're all up to you. Have fun with them.